All right, we got an exponential function here, but there's nothing wrong with that. E to the x is continuous everywhere, and minus 3 doesn't really change it, just moves the graph down 3. So we can say that this function is continuous on our entire interval, and that's our first thing, as always. Checking condition 1. F of x is continuous everywhere, since it is an exponential function. Okay. And then number 2 is showing that the y values at our endpoints are surrounding 0. So just got to find the y values at the endpoints. So f of 1 is e to the 1 minus 3. Well, that's less than 0. And f of 2, this is less than 0 because e is less than 3. E is 2.7 something, so it's less than 3. F of 2 is e squared minus 3. Well, that's greater than 0. Because e squared is bigger than 2. I'm sorry, e is bigger than 2, so e squared is bigger than 4. And then minus 3, that's bigger than 1, so it's positive, it's greater than 0. And we have that f of 1 is less than 0, while f of 2 is greater than 0. So the conditions for the IVT have been met. So, since the conditions for IVT have been met, we know that our function here, which is f of x, so I'm going to say f of c has to equal 0 somewhere for some c value. I'm running out of room here, but I'm going to squeeze down here on the interval we've been given, 1 to 2. Now they want us to find it. So they're saying where, if IVT applies, find the 0. So we know it has to equal 0 somewhere between 1 and 2. Well, to find the 0 of a function, you just set the function equal to 0. And when you solve this, you add 3 to both sides. So you get 3 is equal to e to the x. You get the natural log of both sides. So ln of 3 is equal to x. And that is somewhere between 1 and 2.